welcome to the webinar on embodied carbon and building materials, a hidden heavyweight for the climate. We will discuss today kind of like what the issue is, but also how financing and policy can help to reduce the footprint of building materials and construction. So my name is Zinecker. I work for the Program for Energy Efficiency in Buildings, or short PEEB, which is a French-German initiative and then implemented by the French Development Bank, AFD, GIZ, and ADEME. And we organized this webinar today in cooperation with our colleagues from the program ABC 21, then with the ACT initiative, also Global Alliance for Buildings and Construction. We're very excited to have really a panel of excellent speakers here with us today. They come from industry, academia, international organizations. So I think we'll have a very interesting discussion today. So just to say, building materials, I think we all know. It is a topic that took some time to sink in. I mean, some people have worked in it for a long time. PEEB really started looking into this in 2019, and we're very happy to discuss it here today, because I think we're also at the situation where kind of like the topic is slowly gaining the importance and the attention that it really deserves. Just to quickly wrap up the facts. I think we all know that basically, we're building an area the size of Paris every week, which is quite a staggering fact. And this has, of course, a huge impact on the climate. So, I mean, the rough figure that we know is that, basically building materials and construction are responsible for 10% of the global greenhouse gas emissions. I think we're still, in many countries, we see a lot of construction activity. With kind of like economic development, growing populations, urbanization, just really a need for housing and construction or buildings around the globe. But the good news is, the solutions are already there. No, I think we don't have to kind of like invent a lot of new technology, but I think the ingredients are pretty much there. Companies across the globe have found solutions how we can actually address this issue. The question, though, is how can we get these solutions and to get to scale? No? Because often it exists a bit in a niche, it exists with pioneers, and we want to get this really rolled out. This is the question that we want to discuss today with you. And then maybe just like full transparency, we don't have all the answers. We're just as much interested in what our presenters have to say as you are. I think some of the answers are there and some of them will still have to be developed as we go forward. So just really quickly what awaits you today in terms of the agenda. So we will have one curtain raiser from my colleague, Jérémy Bourgault. He will introduce kind of what strategies we could do, what the problem is, what strategies we could choose. And then we will have like 3 experts talking about aspects of how we can address the building materials. So we look into how we can avoid kind of a lot of the kind of using so much materials. We will look into other materials, and we will look into decarbonizing cement, steel, and other conventional materials. And this is then the basis for the discussion, because we want to think about kind of, now we know the solutions, what can actually be done to accelerate this. Yeah, and I think without much further ado, we can get into the discussion. Just maybe really quickly to say, I mean, this is kind of like a Teams meeting. So basically we can use the chat. And I think we have quite a lot of participants here already. So please do feel free to engage actively, ask all the questions that you might have, ask them to presenters, but maybe also to kind of other people in this chat. Feel free to post something that you find is relevant. We will try to monitor the chat, and basically your questions will also be part of the panel discussion that we have in the end. Because I think we have too many kind of like one-way discussions online, and I think, we have a really great group here today. Okay, so I think with that, I would directly hand over to my colleague, Jérémy Bourgault. So he works for PEEB and he works in AFD, so the French Development Bank. He's an architect and engineer with a kind of knack for policy and urban planning. And he works in PEEB supporting large-scale financing projects with technical advice and financing. And he will present the paper that we co-wrote and which took some time to get to fruition. And we're very happy to, have you here today. Jérémy, the floor is yours.
Yes, thank you very much, Anna. So thank you for the introduction. This presentation is a summary of our understanding of embodied carbon and how it can be addressed. We will look at it from two different angles. First of all, from a building project angle, what are the strategies to reduce our need for additional resources? And then we will look at the major corporate themselves, meaning building materials. So just a quick reminder of the scale of the stakes here. So as Anna mentioned, the size of Paris is added every year, every week, sorry, to the global building floor area. This represents a doubling of the global building floor area by 2060. Most of this growth is happening in Africa, China, and India. So currently, buildings and construction represent 40% of global energy-related greenhouse gas emissions, of which roughly a quarter is so-called embodied carbon. So what embodied carbon is essentially the emissions that were released before we even made use of a building. They mostly come from the provision of building materials and from construction activities, and they represent, as Anna said, about 10% of global energy-related greenhouse gas emissions. The lion's share of these emissions come from the manufacturing of cement and steel, which are very energy-intensive processes. And to a lesser extent, because they are less used in building and construction, but are still very high emitters from aluminium and glass. Another important fact to keep in mind is that the relative weight of embodied carbon will increase as our buildings become more energy efficient. This means that if we want to keep decarbonizing our building sector, we have to look at embodied carbon just as much as we are currently looking into energy efficiency. Another important thing to notice on this diagram is how concentrated in time embodied carbon is added to the total carbon footprint of a building. This means that we have to rethink the way we make our buildings, because there's no way to remove or reduce embodied emissions once they occurred. So we have to keep them in mind from the earliest decision stages onwards, because afterwards the potential for limiting them reduces rapidly. So the first stage where we can that is important is the planning stage. It is, although it's often overlooked, it is important because this is when we can decide how much and where we want to build, and this can have massive consequences on the amount of resources we need. So simple decisions can be to favor retrofitting existing assets over constructing new ones. This is exemplified by this beautiful former water tower that was turned into a student house in Denmark. What can also be done, for instance, is to go for more urban, compact urban spaces, to densify and to favor mixed-use planning in order to decrease our need for additional transport infrastructure, for instance. A central stage is, of course, the design phase. Because the choices we make in terms of architectural shape and materials will have a massive impact, not only on embodied carbon, but also on operational carbon, on the thermal performance of the building, and on its climate resilience and its adaptability. So the decisions that we make at this stage have a massive impact over the behavior, the performance of the building over its entire lifetime and its need for additional resources at later stages. So what we encourage is, in order to understand these interdependencies between embodied carbon and operational carbon, is to take, when possible, a whole life cycle approach in order to better inform design choices. To a lesser extent, construction, refurbishment, and waste management choices can also have an impact. We can, of course, optimize our construction processes, for instance, with a modular design, like on this picture. We can also reduce our future need for additional resources by enabling the reuse and the recycling of building materials through cradle-to-cradle approaches and so-called urban mining. Let's look at the elephant in the room. It's the building materials themselves, because no matter how resource efficient we will become, we'll still need a massive amount of materials to address our growing need for buildings. There's two schools of thoughts we hear of in general. One is more focused on decarbonizing existing industries, and the other one is more focused on the development of alternatives to conventional building materials. What we understand at PEEB is that it's absolutely essential to do both at the same time, simply because there's no way around using concrete and steel, but there's the potential to replace conventional materials in certain situations by more locally relevant and less carbon intensive alternatives. So the first pillar of this approach, avoid, is basically what we looked at previously. It's about the design, the planning, the design, the refurbishment and the waste management choices that we can make in order to reduce our need for additional resources. Shift is about looking into alternative building materials. It's that can be local and renewable, either bio-based like wood, bamboo, or natural fibers such as canes, hemp, and so on. It can be geo-based like clay and earth, and we can also include in this category recycled materials. So these solutions are very context-specific, but if used in the right way, they can massively decrease embodied carbon. They can also support local and circular economies, and they also feature excellent mechanical and thermal properties that can increase the resilience of buildings in the right context. So the difficulty, however, is to get these alternative solutions to a meaningful scale in the face of the challenge of embodied carbon at a global scale. And for that, we need to focus on developing local and circular value chains. We need to make these alternative solutions competitive by accelerating their standardization and certification. And we also have to work on how to better integrate these alternative solutions into our conventional construction techniques. Finally, what we have to do is to improve conventional materials. There's simply no way around the decarbonization of steel, cement, aluminium, glass, and so on. This is currently partly done already by decarbonizing the energy supply with the use of renewable energy. But there's also potential to invest in energy efficiency all along the very intensive production process. And there's a potential to invest in innovation in regards to the chemical processes themselves, and in regard to substitute components that can be recycled or bio-based in order to reduce the carbon footprint of conventional materials. So these are the main strategies that we have identified, and of course, what is the central question for PEEB is how policy, financing, and capacity building can support these strategies in order to reduce embodied carbon. So here's a quick overview of a few first thoughts we've had on this question in PEEB for policy, financing, and capacity building. I think I'm a little bit over time already, so I won't go into details now, but we can of course come back to this slide, because we would be really interested to discuss these options with you and our panelists. Before I hand over to our panelists, let me just quickly mention that you can find more details and all our references in our working paper on our website. And you will find also other reports around the decarbonization of the building sector. Thanks for your attention, and I'm very excited to to hear your insights.
Perfect, Jeremy. Thanks a lot. I think this was the curtain raiser that we needed. And with that, I think we'll move over to the presentations. And just a reminder for everyone in that meeting, if you have questions, you can already start putting them in the chat. And I think you're doing this, and we will get to this later then. So I would like to invite Chitra Vishwanath. She is an architect from India. She's also the founder of Biome Environmental Solutions. And just to say, I think she's been involved in more than 500 projects. That's what we found, and really putting a special focus on ecology of the sites and also the use of basically local resources. I think you also built your own house using local resources, mud, and without the need for air conditioning or even fans. So yeah, I think Chitra, the floor is yours. We're very excited to hear about your work and your ideas about how we can basically avoid an overuse of these resources.
Thank you, Anna. Thank you, PEEB. Thank you, everybody, for inviting and allowing me to share our work. So I'm going to start sharing now.
Right.
So,
yes, looks
so where do we get our materials from? So I'm coming to the fact of materials straight away. And I think what we got from Paul was very nice about avoid, shift, and improve. So what does Biome do? So we source the materials closest to the need. So where do we get the best material, but how long a distance it has to be taken? And to see nothing as a waste and design in such a way that nothing is wasted. So closest to the waste, so this is our house, we call it Sanssouci without problems. So it's the basement. The basement is a space which is 22 degrees throughout the year. So the best place to be in the summer and also in the winter of Bangalore. And that's where we get the earth from to build everything above. Plus also we get the earth for the terrace, we call it our rice field. Nothing gets wasted. So this is the kind of soil we get in Bangalore, though soil is very versatile. This is the lovable soil, which is in fact made into blocks, and these are sun-cured. So, and it's all with human energy. We prefer to talk about working with people because India has lots of people, and by the way, India and Africa will add lots of Paris throughout the world because we are really behind in infrastructure and the need is there. So this gives the calories to the people rather than using machines. So there is again the pollution quotient is very low. And the basements are really great places to be in. But then, is it only homes? So this is a school which we dug partly underground, but the classes in the ground floor connect to the play area. So even the play area is dug underground. We get lots of earth to make this whole 1,500 square meter of the school, plus also for future uses. Then this is about 8,000 square feet, 800 square meters of an office space, where you can see at the bottom here is a basement. We've cut it, we've taken the earth, we even made the wall of the basement and cut around it so that it doesn't get wet, and use the whole thing for building above. Then it's a larger development in 80 acres of land. And here you start wondering, where do you bring the earth from? A farm nearby wanted it to be flattened. You got earth from there, just a kilometer. In the site, in the 80 acres, big ponds, large ponds of 100 square meters. So you could pick that earth. So different places you design to make the whole place be, giving you the volume of soil to make your buildings with. So these are buildings photograph taken after 13 years. Designed according to the region. This is a place where it rains 4,500 mm a year. You need to work at the roof so that the walls are safe from water ingress. So then what's beautiful about earth construction and the very material earth is that it's very versatile. It can be used for walling, it can be used for roofing, foundations, everywhere. So this is the way you do a drawing so that you can give it to people to learn how to build, as well as make it very simple. So that is a very important factor. How do you make dissemination happen? How do you see to it that people, local people, will be able to learn how to build with earth? So this is not in Bangalore, it's closer to Mumbai, in a village. They're making the blocks, they're making the roofs. And this is in Nigeria, again, blocks and walls done. And it has become, this group has started now making a lot of buildings with earth blocks. The machines went from India, and we trained them, my colleague Sheel trained them, and afterwards now for past 12 years, they're making a lot of buildings. So this is also important for us. The systems have to be simpler to adapt.
Yeah.
And then the
Chitra,
buildings are
just
within
one
the
second,
city.
sorry.
None of these buildings we do
Chitra?
in Biome are, the second house for a very rich person who has a fancy to have earth house. This is right in the middle of the city, a middle class home. And on the right, you see two friends having their own homes. And it's such a beautiful material that it doesn't leave you only making plain, simple walls. You can really craft, and craft is important because the aha moment has to come. And there's various ways of using the material. Whereas if you use only steel, there is a certain, I would say it gets binding. The concrete, you have to make it straight. But here, there's much more possibility without giving up on the creativity. Then,
And
again,
Chitra, just one second. Can you hear
a
me?
small plot where we couldn't make the blocks at the site, you used rammed dirt. Looking within the city, this is rammed dirt. Every day you bring certain amount of soil, ram it, and let the walls go up. And then there is, with the beauty of the light inside these spaces, is subdued because it's a hot country. And no painting at all, which is one of the most polluting elements of a construction. Then, like what I said, nothing goes as waste. So buildings become waste sink. They embody the waste which otherwise people have thrown around. And using construction debt into construction, into making of the building. So here, the office goes like rack pickers. We pick up plastics and put it underground as a TPC layer. And so note, most of these places have the water table very low, so no way the plastics is going to leach at all. And do a rammed dirt foundation. Bangalore is the silicon city of India, and this is a roof done where these were embedded inside the concrete to reduce the amount of concrete used, the keyboards. When we didn't have the policy of recycling electronic waste, using of construction waste. So there's a stone cut, again used on the roof itself. Here is a shop of a recycler where he had a lot of louvers. Those louvers were used in this building as a screening to reduce the heat ingress into this corner where paper was stored. Now, our cities are changing. The city bylaws change, the way of using the land changes, and the old buildings come down. Can we reuse the old building itself, the material? So on the left is a building 80 years old, which we pulled down and made the new building on the right. While we included earth blocks, most of the material we reused. So you see the stone was earlier in the building on the right. When we brought down the building, we used the material into the foundation, made a foundation called well foundation, put all the material there, so not a conventional foundation, did a grade B, and the rest of the building comes up. Without cutting trees, without hindering any of the work around, and without taking our waste to, usually in Bangalore, to a lake. Here, in fact, this building now accommodates more people than earlier. The 3 families than earlier, just 3 people. And also now to look at how do you design that in the very design itself that there will be no waste. This is structure of a school we did about 100 square meters, where from the foundation to the roof, everything could be reused, either as completely the same building or every piece could be reused in another building. So there's a combination here. Here we have improved, like Paul said, on the columns. The columns are of steel, but very minimal where it's needed. And they are all bolted, so you could open up everything and nothing will go waste. The walls are of paper, so it will be composted, cradle to cradle. The floor is of tiles which could be removed because they're not jointed by cement, they're based on quarry dust. So you could remove the flooring, you could remove every piece of this building and put it elsewhere too. And this was because it was required by the project itself. It was only available, the land was only available for 5 years. That's the building here. And that's it. Thank you. Am I less than 10 minutes? But I hope somebody else uses this. Thank you very much.
Wonderful. Thanks a lot, Chitra. That was really interesting. And I think you already got a few questions in the chat that we will get to later. Just maybe one point. I think the sound, I mean, we couldn't hear you so well. I mean, I could hear you, but it was a little bit strained. So maybe I think, you know, for the panel discussion, either we have to check about kind of like switching off the video. But yeah, I think we could follow, and I hope it was okay for the people in the audience as well. Great, but yeah, I think that set us up for kind of resource efficiency and circularity in buildings. We will now move to kind of like that second, like Jérémy called it, school of thought. So basically that question of how can we shift to other materials, local, bio-based, geo-based materials. And yeah, I think we're very happy to have Asmae Khaldoun. She's a professor at Al-Akhwayn University. I read she has 2 PhDs, so one in physical chemistry and one in physics. And yeah, I think her research really has received a lot of awards and funding, and she's working closely also as part of the ABC 21 project. Yeah, and Asmae, we're very excited to hear from you, kind of like what we have in our hands as alternatives and how we can bring that to scale. So floor is yours.
Okay, thank you very much for the invitation. I will share with you my presentation, try not to do it, okay? So to start.
Oh, and maybe I forgot to say she's joining us from Morocco.
Yes, so do you see my presentation?
Yes, we see it, and if you could put it in presentation mode.
Yes, I will. Okay, is that fine?
That's absolutely fine.
Okay, thank you very much. So thank you for inviting me. I will be speaking about bioclimatic materials that we did in the framework of the Africa-Europe bioclimatic building for the 21st century. Okay, so to start, as you already mentioned, in 2020, it was reported that 38% of the total global energy related CO2 emission is related to constructions and buildings activities. So, and of course, it's expected that this number will increase over the time exponentially, mainly because in Africa, in developing countries, in Africa and Asia, there are lots of constructions and expansion of cities and growth in population. So this is why in this project, in ABC 21 project, we give a very special interest to design that involve local bioclimatic approaches, means local material, bioclimatic construction material, and also construction processes. So the aim, of course, is to reduce the energy consumption during the manufacturing, during the building of the construction, and the energy demand for cooling, because mainly now in Europe, there are also a rise in temperature, so the need of cooling is now more and more important. So if we can manage to decrease the cooling load, it will be also very good. So of course, this, as you mentioned before, so the solutions on the bioclimatic constructions are already here, and you in Africa and Europe and all over the world, a huge history of construction using earth and so on now the monuments are witnessing of the strength and the durability of this kind of constructions. So of course, so the information is here and existing. It needs just to be like understood and also redisseminated and also redeveloped, maybe more adapted to different regions and also to our actual context of living. So this project, as you can see, is a huge project. There are plenty of information that should be gathered. And so there are partners from Europe and from Africa, many institutions, and mainly our goal or our task in this project is to focus on materials, so and bioclimatic materials. So the first reports that we published that you can find also in our in communication of the ABC 21, you can find we gather all information of all active organization and active manufacturers that produce local bioclimatic materials and also constructions. So we gather all the information in a table. So we have, you can find the country, the company, the contact, even all kind of contacts of this company, like the website and so on, their activities and example of their projects and achievements. So this will facilitate for everyone who wanted to do this kind of activities to contact this kind of manufacturers, because we say that there are plenty of them, but they are scattered and not really correlating. Okay, in the other reports, normally we deal because we are scientists and this is our so I'm actively working on research related to bioclimatic materials. So this is why it was interesting for us to look for different type of bioclimatic materials, because I actually work in my group only on clay products with additives and bricks. So here I was exposed also to more interesting also and more variety of kind of bioclimatic materials. So as you can see, this kind of materials are really, so the spectrum is very broad and it's very large. So we try to gather them in terms of groups and also the main basic products, because you can find formulations that include this kind of products at different proportions. But at least here you found the main products that are used in the bioclimatic constructions. So we can cite the earth-based constructions like the adobe and clay brick with additives, the ramped earth, the earth bag constructions. You can also find as the very widely used stone constructions, the cork-based bricks that can be also used for construction as for the installation, the hemp grids, the straw bale constructions, the thatched roof, the taifa-based bricks, the wood, the bamboo, and the wool. So these are all type of material that are coming originally from minerals or organic resources, can be from plants or from animal or organic animal resources, like for example the wool. So the methodology that we followed in this study, so of course we saw the composition, the properties analysis, mean the main important properties like the mechanical properties, the thermal properties, of course the obtainments and extraction process, the construction processes using this kind of application. And in the end, we try to come up with some cost assessment to make some comparative study of this kind of constructions and regulation of the bioclimatic constructions and materials. So here I can show you some nice example of earth-based constructions. So you can see the adobe. So the adobe is mainly made from clay, with some natural additive like fibers, like straw and water. So they are mainly dried on the nature. So this kind of blocks will be used in like constructions, and you can even use them, as you can see in the Nobian vault technique, where they are used using the arcs. So you don't even need any other stuff to improve their stability. You can find also the ramped earth. So you can see the ramped earth, so they can give us very nice and beautiful kind of constructions. So these are modern constructions that are using the ramped earth. You can see the earth bag construction. There are plenty of varieties of them. So they are easy to use, and they are mainly using the local. They don't have any specific, say, need for materials. They can have some proportion of clay to like soil, and then you have some additional additive like some lime to improve the stability. Then you can do the construction. Mainly use the dome construction, also used for this kind of earth bag construction. And we mentioned the clay brick with additives. So this kind of bricks are more stable, I would say, than the adobe, because they are burnt at, they are not really burnt, but they are produced at relatively low temperature. They can be produced at 100 or 200 to just evaporate the water, but also to create some binding inside the bricks. This kind of bricks with additive, we can add many type of additive, and mainly we use the additive because of the properties of the clay bricks. We see that the clay bricks will have high density. They will have also some weak mechanical properties, and also their thermal properties that not are good as we want. So if you add the additive, mainly you improve the thermal properties. But whenever you add additive, you improve the thermal properties, but this will be also against the mechanical properties. For the mechanical properties will decrease also. So, but using several construction or type of additives, you can find that with some specific additive, we can have very good results. So it means that we will improve the mechanical properties and the thermal properties. So this is like the key. We're doing several research in several type of fibers, and mainly for fibers at low concentration, you can have both the improvements in thermal properties and mechanical properties at low concentration of fibers. When you increase it, you have the decrease of the mechanical properties. So we can see, depending on the type of construction, using the same, for example, clay, or you will have, and soil for earth bags, you have some conductivities that are quite high compared to the unfired clay bricks or instabilized rammed earth. So this is, of course, just a comparative study that I will just show you in the end, because I see that the time is quite short. So I will also speak about the organic residue-based blocks. You can see here that we can have very interesting type of materials. If we have like supports, for example, a wooden support, you can even build with this kind of material, and you can see that their thermal conductivity is very interesting, mainly for the Taifa. Taifa has very, very interesting properties, and you can use several parts of the Taifa product, and you can have several type also of products, and of course, depending on the formulation. The stone, as we said, we can see that the stone will have several different properties depending on their type, because we know that we can have organic origin, you have the metamorphic, and you have the sedimentary origin. So, of course, the volcanic rocks will have very interesting thermal properties, others will have less, but of course, the compressive strength and all mechanical properties of stones can make them very competitive to the normal or the conventional constructions. So there are also very interesting type of construction using the straw, because the straw is very abundant and also has very good thermal conductivity. So this is just an example of a way of constructing with the straw balls. So here I will show you like a small like summary of the properties. So for if I compare the stones to other type of constructions, obviously they have very good mechanical properties that are followed with the unfired clay bricks. Depending on the formulation of the unfired clay bricks, you can raise their compressive strength to a very interesting values. For the others, they can be used but by other supports, but also used as installation materials and second layers. For the thermal properties, you can see that the thermal conductivity is very interesting for the sheep wool, for the straw balls, and also for the taifa, but you can see that it is less for the rammed earth and for the earth bag constructions. So additional insulation should be done in this kind of constructions. For earth, of course, for stone construction, you can see that we can have very nice mechanical and thermal properties. Okay, with that, I just gave you like a summary mainly on the properties, the mechanical and the thermal properties, the most important properties for constructions, and open to any other questions if you have. And thank you very much.
Perfect. So thank you very much for that very impressive presentation. I can already warn you for the discussion later that there is a lot of questions, a lot of them also around, you know, getting this to scale. So I think you have a bit of time to think about it before we move into the discussion. And now I would actually like to invite kind of the last, you know, piece of the puzzle, but a very important one, of course. The question of how do we address well, basically, you know, the main materials that we're using, especially concrete, steel, etc. And we have two presenters for this, and I hear a little echo, but I think it's fine. Yes, so we have two presenters. Because I think it's a it's a big chunk that they want to attack. So we have two, which is very good. So we have Marlène Dresch from the ACT Initiative, and we have Anupam Badola. So on the one hand, Marlène, she's well, an engineer and environmental scientist, and also has a PhD with more than 20 years of experience in that field. She will start off basically giving the frame of like how, you know, how to work with companies on the topic, and then we from well, a company themselves, right? Like how can you, like, you know, what's your role in this? Like, you know, it's not an easy one, but how do you attack it? And we have an excellent speaker for this. We have Anupam Badola. He is actually also, like, I learned, a sustainability professional. He started out with a degree in environmental studies as well. So he has 16 years of experience in the heavy industry, in cement. So he works at Dalmia Cement, which was founded in 1939, I learned, and manufactures 36 million tons per year. And they have 14 cement plants spread across India. So we also research that the company has the lowest carbon footprint in the cement world globally. We could not verify this, but we're very excited to hear you from yourself, kind of about your work, and basically what takeaways we could take from that. Without much further ado, I think, Marlène, we see your presentation. If you could just put it in presentation mode, I think that we're good to go. Floor is yours.
Is that all right?
Perfect.
Thank you. Thank you for the invitation. So hello, everybody. My name is Marlène Dresch. I work for the ACT Initiative at ADEME, the French Agency for Ecological Transition. And today I'm here to talk about how ACT can help decarbonize conventional materials such as cement and steel. First, I would like to give an insight of the challenges that conventional material producer will have to meet to contribute to the Paris Agreement mitigation goal. So let's have a look at charts coming from the International Energy Agency. The first one is about iron and steel sector. These charts represent the global CO2 emission for this sector from from 2019 to 2050 and even beyond. If we go on business as usual, we will follow the upper curve, and that is not at all aligned with the Paris Agreement goal. The lowest curve, called SDS for a sustainable development scenario, is aligned with the Paris Agreement goal and will require huge changes in the sectors to achieve a 54% reduction in absolute emissions until 2050. So the main decarbonization levers for the iron and steel sector are recycling and material efficiency. So use less steel, but use it better. Enhance of technology performance, also shifts in fuels and processes to use green electricity, bioenergy, and green hydrogen. And finally, CCUS, which is carbon capture, use and storage. So now here is the same charts for the cement sectors. So to be aligned with the Paris Agreement goal, the sector must achieve a 64% emission reduction till 2050. This will also require huge changes, and the main decarbonization levers are avoided demand of cement, so use other material and recycle. So actually, this is the shift and avoid strategy that we have just heard about. Second decarbonization lever is to lower the clinker to cement ratio and also CCUS. So to further illustrate that the changes are huge, the last chart shows for cement and iron and steel sectors what would be the route of production in 2030 and 2050. As you can see for both sectors, the conventional routes, which are in dark gray, are mainstream in 2020, and in 2050, the innovative routes in light gray and green would be dominant. So as the sector have long life plans, decision-making now will shape what will be the sectors in 2050. So it is just urgent that this sector start right now the low carbon transition and define clear transition plan aligned with the Paris Goal Agreement. So, and this is where ACT can help. ACT stands for Assessing Low Carbon Transition. ACT is a joint voluntary initiative at global level, co-founded by ADEME and CDP. And ACT is precisely about companies' low carbon strategy. So what does ACT provide? On one hand, we provide a methodology and a set of tools to help companies develop and implement a low carbon strategy and the associated action plan. It's what we called ACT step by step. And on the other hand, we provide also sectoral methodology to assess the alignment of a company's low carbon strategy with the Paris Agreement goal. We have one methodology for cement and one for iron and steel, and also one for building. We have a future-oriented and holistic approach, which analyzes company strategy against qualitative and quantitative indicators, considering different aspects of the strategy, targets, investment in plants and in R&D, carbon performance of sold products, and more qualitative aspects such as how the company involves the value chain in the process and how the business model of the company is shifting to stay profitable in a low carbon economy. Finally, how ACT can help decarbonize conventional material, ACT help companies understand their readiness to transition to a low carbon economy and also identify opportunities for improvement. And ACT can also help stakeholders challenge company and establish dialogue, whether the stakeholder be an investor, an NGO, or a policymaker. Sorry. So thank you very much for your attention. I just wanted to wrap up saying that company producing cement, iron, and steel, and also aluminium, etc., must take action now and establish low carbon strategy aligned with the Paris Goal agreement. So ACT provides tool to help and create accountability. Thank you very much for your attention, and I will now hand over to Anupam Badola from Dalmia Cement. Dalmia Cement kindly helped the ACT initiative to experiment the ACT cement methodology. So thank you very much.
Thank you, Marlène, and thank you, Anna, for the introduction. We are one of the lowest carbon footprint cement producer globally. In fact, we were part of the ACT initiative, which is very nice methodology being developed by the ACT initiative. And during this test, we were also identified as, in fact, lowest carbon footprint cement. And in 2018, also there was one CDP study which was carried out for the specific cement industry globally. And there, Dalmia Cement was considered one of the, in fact, the lowest carbon footprint cement company. So once again, thank you very much for inviting me to this interesting and important discussion on building materials with specific context on financing and policy support needed for the decarbonization of building materials. The decarbonization of the global economy is inevitable because more than 90% of the global GDP is now subscribing to net zero, and cement industry emits nearly 7% of the anthropogenic GHG emissions. And as a core sector, it also needs to reduce the GHG emissions. There are alternative solutions, as we can see, and we have seen in the previous presentations. But the challenge is scale. For example, we have produced globally around 4.2 to 4.3 billion tons of cement in the financial year 20. So this is the scale, and in order to reach to this scale, definitely the first priority is to reduce the GHG emissions from the building material sector. And good point is few industry players have proactively taken the stand towards net zero transition in the sector. And before it has happened, before the such global economic transitions were announced. For example, our company Dalmia Cement, we committed to become carbon negative by 2040, and we did it in 2018 itself. We are proud that our conversation and ambition to net zero in heavy industry sector has become a catalyst. Within 2 years of time, the global cement industry, led by GCCA, announced the roadmap to reduce GHG emissions and become net zero concrete by 2050. At Dalmia Cement, we have been amplifying our work on first of its kind decarbonization technologies, along with an accelerated approach on existing levers of materials and resource efficiency. We have dry process kilns with calciners as a common practice, besides our waste heat recovery and renewable power generation capacity increasing day by day with new installations. We are moving strongly with our commitments to non-fossil fuel electricity and non-fossil fuel based thermal energy use in our cement plants. As per our projection of growth, by 2025 itself, we will have nearly 50% of the electricity that will be replaced from the non-fossil fuel sources. And similarly, nearly 50% of the thermal energy would be replaced from non-fossil fuel sources. So this is the growth trajectory we are working on, and we are committed to bring this change in our manufacturing process. As for our experience also, clean and green is profitable and sustainable, and it makes business sense to follow decarbonization journey. So far, we have reduced CO2 emissions in our cement plants with adoption of energy efficiency, circular economy principles, energy recovery, use of waste as raw material or fuels, renewable energy, and deployment of heavy-duty electric vehicles. However, at the same time, there's another wave of technologies which is emerging, and for deep decarbonization, that new wave of technology is required, which are green hydrogen use, renewables coupled with storage, solar calcination, and most importantly, carbon capture, storage, and utilization, which is very essential for 55% process emissions which happen from the dissociation of the limestone in the cement kiln. This is like an entering into an unknown jungle of technological advancement where, a positive mindset, right policies, better investment scenarios, green product demand, and sustainable markets are needed to support this new net zero transition. Some of the key enablers for this transition, particularly in the developing countries, and in fact, very crucial ones, and they would be towards, if there is more focus on embodied carbon footprints. So currently what is happening is in the building codes, what we see more focus on operational efficiencies. But I think if there are more weightage in the green rating system, building codes towards the embodied carbon footprints, so then there can be more support for the green market development as well as green demand from the builders and in fact the infrastructure sector who wish to develop the green buildings. Secondly, setting up the industrial scale demonstration projects, particularly on the new technologies like green hydrogen, carbon capture and utilization and storage, that is currently missing in the developing countries. In the developed countries, this action has started taking place through the action of presently applicable carbon markets, also the green grants and climate finance available in the developed countries. But in developing countries, this has not yet started. And therefore, there needs to be some demonstration project to set up in developing countries to have economic as well as affordable technology options. Thirdly, project-based risk finance is completely missing from the whole climate discussion debate. The $100 billion USD promise may be useful to create some project-based risk financing model for demonstration projects in the developing countries. And this can go a long way. We have seen how demonstration projects help in shaping the policy and in shaping the know-how in the particular developing country. Another lever is access to global carbon markets. We have seen how global carbon markets have helped in dissemination of projects of decarbonization with lower payback periods and how those technologies were implemented. There might be some areas where carbon markets have to be made more robust, but this would be accessible for the better technological deployment. And finally, building construction sector has a lot of demand from the public sector. Nearly 50 to 60% demand is from the public sector. And therefore, it is very, very critical that there's a green procurement from the public sector itself, because we still have existing solutions which have not been fully utilized, for example, blended cement. So our carbon footprint is 492 kg per ton of cement. 10 years back, it was around 700. From 700, we have reached to 492. And our target to reach carbon negative by 2040. So we have existing solutions, and those existing solutions can be further accelerated by green public procurement demand, such as use of blended cement in all the public constructions and infrastructure development activities. So these are some key areas of policy and finance, particularly which are needed in developing countries, because where the most of the construction will take place, and these policies and these financial levers would emerge as winner in order to implement low carbon technologies and zero carbon technologies by 2050 in the cement sector. Thank you so much.
Well, thanks very much to you. I mean, this was an extremely round and complete presentation on the one and what you're doing at your company, but also I think you're really leading us already into the discussion of, well, what needs to happen next. No, I think you, well, basically put in a few very concrete suggestions, right? Yeah, I think this sets us up perfectly for the discussion now. I think we have 25 minutes where we can build on what we just heard from our presenters. I think I will also try to bring in the questions from the chat. And yeah, I would like to ask our quite large panel to switch on their cameras to make us feel as if we're a little bit sitting in the same room. And I think you know a few of our presenters already, and I will welcome our presenters that also joined. So for one of them, we have Anna Dyson, and she is joining us from Yale University. So she is well, a professor of sustainable architecture, of sustainable architectural design at the School of Environment. She's also the founding director at the Yale Center for Ecosystems and Architecture. And then we have Luca De Giovannetti, who is a manager at the World Business Council for Sustainable Development, also someone who has embodied carbon or whole life carbon really at its heart. So World Business Council is very active in on that front, has published several reports, works with investors. So yeah, I think we're very happy to have you joining the panel. And yeah, I would say let's kick off the discussion. Maybe we give the floor first to kind of like our new presenters. Maybe I would actually start with Luca, right? Because I think you're also working a lot with companies. And basically, I think we want to discuss now that question of, well, you know, we heard there are solutions. Already in the chat, we had a few questions about, well, very interesting, but can they really get to scale? Yeah, and I think also our presenters would be great to hear from you, your thoughts about this. But yeah, Luca, what is your take? I mean, what are the ways to basically get to scale? How could policy, how could finance support this? You know, is this just something that can stay in a niche and that's not realistic to basically, you know, integrate into kind of like that average normal building that we know will have to be built in the next decades? Luca.
Yeah, thanks for the invite. Thanks for the opportunity to share a bit of our work as well in this space. And first of all, I think what is important is that when we speak about low carbon materials, it's not just about the production of the material, or there is kind of one better than the other. We need to make sure that we always speak about carbon material and technology neutral approaches, because it's really about the use of the material that makes it low carbon. It's not just about the material. And that's our approach as well at WBCSD, to really kind of make sure that we look at the performance of the final product. So really looking at how does that eventually, when you assemble all the elements together, that you have a low carbon product. And as Jérémy showed in the graph before, you know, in our report we did on where do we stand based on our building system carbon framework. When we look at the whole life carbon approach, then you can really understand the aspect about the embodied carbon upfront, the embodied carbon during the life cycle, and then the operational carbon. And that's where it's important kind of to look at how you combine all that. And then when it comes to that, is actually how do we incentivize, how do we stimulate this kind of whole life carbon performance? Driving embodied carbon specifically when it comes to in the short term, being the fact that embodied carbon is kind of released before the building is operational. And that's also with another publication on decarbonizing construction, where we provide 50 different measures that investor can look to implement, practical measure that investor can look on how can they drive embodied carbon reduction. But with this, I think what we actually working now together with the Global Alliance for Building and Construction in the market transformation work area is really how do we bring all the player and stakeholder together to achieve the decarbonization. And that's where we bring together the idea of business, government, finance, and academia as all enabler, and also responsibilize them to be part of the transition. So in that market transformation work that we published at the COP last year, it was how do you make sure that you have kind of using by two main enablers, being a common vision, a common language across the whole system. And in this case, the GlobalABC vision is perfect of halving emission by 2030, net zero by 2050. So, and making sure that we all speak about the 40% of emissions. So, and in this, there is the 28% of operational carbon, and as well this 11% of the embodied carbon. So we really need to make sure that the built environment is seen as critical and relevant sector to decarbonize. And then linked to that, the importance of radical and deep collaboration. This was actually very well profiled at COP. I think throughout the 2 weeks, built environment was very present. And really this collaboration across the different stakeholders is really important. And then with the market transformation, there is 3 key levers that drive the decarbonization. One is making sure that we speak about all life carbon, and this driving of all life carbon across all the projects. So really aligning on all life carbon narrative. So, and making sure that this is aligned for all players. Then the second one is integrate carbon cost and price in the decisions. So making sure that carbon cost is integrated in the decision process, either as a shadow price or as a visible price, but the understanding that enables them to make decisions based not only on cost. And the third part is really to drive the supply and demand dynamics to decarbonize. So we need to have a stronger demand for decarbonization, and that makes then the change in the supply. By having a stronger demand for low carbon solutions, that makes the activate all the players, including especially the private sector, to deliver to these low carbon solutions. So, and in this, I mean, I encourage you to look at this market transformation narrative. Then you can identify what is the role of finance to achieve these specific levers, which enable then all the other players to achieve the transformation. So I could cite some, but I guess, you know, I don't want to take too much time, but this is really kind of important to make sure that we link all the players together to work together at the same time.
Thank you, Luca. Yeah. So I think well noted. I think we heard it in several instances already. Like kind of like, first of all, you have to make it visible, right? Because it's not something that you know, you look at a house and it might just look the same, right? So the question is like, how can you make that difference in carbon content visible? And then the question of like, how do you, well, calculate it economically? And then that whole question of like, yeah, how do you actually stimulate demand and supply? So maybe I'll look over, look in the same direction, but I look over to Anna Dyson from Yale University. So I think, Anna, you've worked on a lot of like very innovative projects in the past, but you've also seen kind of like how that, well, whole landscape is changing quite dynamically. So what is your take? I mean, what do we need, right? Like, I mean, do we need more information? How do we get there? And like, how could policy and finance really kind of like, you know, give that, well, demand and supply push that we really need?
Yeah, that's a great question. First of all, thank you so much for the beautiful presentations. It's a pleasure to be here. Well, I probably would reiterate a lot of what people have said already. And I do think there's some comments in the chat, which I think I would like to highlight as well, that are really important, which is that we need to be supporting people all the way across the built environment process through regulatory processes and other processes that will really incentivize all of these wonderful approaches. And also, certainly we could always have way more information in the process and better information, both in terms of materials and methods, but also in terms of the carbon composition and sort of overall impact, environmental impact of materials. So I would say one of the first thing that's really important at the local level is that we need to transition towards performance-based building codes that will really reward and potentially make visible through tickets or certifications or passports these processes. So if it's performance-based, that means, just like you saw such a range of approaches, that decision makers on the ground can be adaptable with integrated systems and maybe go at it from multiple different material supply chains, etc., both local and beyond. We also really do need international regulatory bodies, and these bodies need to combine in, let's say, it's a material passport system or a ticket system that combines impacts on embodied energy with labor practices, human rights, and of course the rights of non-human living systems. So that means we need to we can use these levers if we start to combine the overall impact on biodiversity and the work of the geobiosphere of building extraction of material products, or even biogenic or bio-based material practices might also, in certain cases, have, for example, negative impacts, not positive overall environmental impacts. If we're, for example, replacing old growth forests with timber in some areas, might not be it might not be recommended. So we need to have very adaptable and very specific international regulatory bodies that can really look at the combined impacts on living systems and on health and well-being across the board. So that also then gets us to the point of information. How do we have all of these different emerging practices for life cycle analysis assessments and embodied carbon assessments. We've seen some today, some wonderful approaches that are emerging that will be very, very important. I love the ACT acronym. For example, I just want to say I think you have the best acronym of anyone, ACT, ACT, because that's what we have to do. We have to work with what we have, and we have to provide the support now and then keep increasing information in the process. So how do we get that visibility for standardized practices, meaning that we can really understand across the board the assessments on from extraction of materials, the industrial processes, the implementation and the maintenance processes. I just want to reinforce what Luca has just said. It's so important when we're looking at things to relate embodied energy to operational energy. And then I would say also very, very important end of life processes and the circularity or the impact on overall environmental health has to be part of those tickets or those passports. And for that, we would really need sort of very accessible portals for stakeholders across the process that are where the information can be understood, not just by experts, but can also be understood by multiple decision makers from the stakeholders, including obviously the property owners, municipal level, government level, but on the ground decision makers that are making the design decisions about how to implement these material processes.
Thank you, Anna. Yeah, and I think you're touching a very important point, no, about kind of like on the one hand, all the information that we have about different materials, no, and sometimes the information that we have and the one that we don't have, and basically how to translate that into easily made decisions. No, I think that's kind of the challenge. And maybe I think with that, I would say maybe to Asmae, Anupam, and maybe Chitra, because I think we had really this question in the chat about kind of, well, getting to scale, right? I mean, do you see that there's already kind of a lot of demand around kind of the materials that you described, do they still exist in a niche? And if so, I mean, what would be needed to kind of get them out? And I mean, just with a view to the time, I think we have about 10 minutes left, so I think we need short, crisp answers. But yeah, it would be great to hear your thoughts on this. And I also I see there's a few questions coming in the chat directed to individual people. So kind of just the view to the time, I think great if we can also use the chat to basically maybe answer some of those. So who would like to go first? I think I have Asmae to the left, so maybe we do Asmae, Anupam, and Chitra.
Okay, so so your question. So can you please repeat your question, or maybe I answer the question of scale up the the production,
exactly.
as you said.
Exactly.
Okay.
What is needed? Kind of this question.
I am, to be honest, I am a researcher. So my research in the lab shows me that it's possible and it's really possible. But what I would like to add is that maybe we can see that a very interesting opportunity, because now in this world that we see that this switch to digitalization, so we will lose a lot of jobs, but we can see here an increase of demand on labor job, meaning that we can create jobs for people who can work on this kind of field, because it really heavily needs people to work with hands, and so you cannot use a lot of machinery in many of this kind of applications. Of course, we can develop more and more, but still until now, with what we have in the time being, we have something that can be done. And of course, if I would like to answer the question with the wrapped earth, if you use local material, you do a good characterization of your material before and you choose the right formulation, you can have better stability and with very low price and very nice aesthetics of the walls. So this is something what you for sure. It's low cost than the other construction because we did also our calculation, but taking into account that you are using the right, like the local soil available in the region. And this is mainly what I'm doing in my research, trying to make each soil suitable. So what we do, we characterize the soil. And for example, and we compare it to, like I have, for example, a stable brick, okay, very nice industrial brick, and they will take a soil from a local region, and they will do the characterization. I will see the missing parts. So for example, I have like an additive, which is a swollen clay that I don't have in my soil. So I will just add this 3% or 4%, which is not very high. So I can improve the quality of the bricks that I can make from the land that I bought to make my construction. So this is the goal after all. So I will add something else that I liked from Anna, what she said. I think local is something very interesting because even the policy should be local and should be adaptable to the regions, to the countries. Because in one country, for example, we do have a lot of trees, so using wood will not be a problem. So for in other countries, using wood would be a huge problem, even if it's a bioclimatic material. So this is why I said we need to have policies that are also local, not just universal kind of policies. And that's it.
Thank you. I would like to give the floor to Anupam. I think you gave us a few pointers already, but like, you know, are people already knocking at your door and kind of like asking for that low carbon cement, or do you see there's still kind of like room for a bigger uptake, or maybe even like your competition moving in the same direction?
Thanks, Anna. I completely agree with other speakers that local is a solution and alternative materials should also be the choice. But at the same time, scalability, as I was saying earlier, is a major challenge because even to reach 10% of the conventional material, it will take a lot of time to reach to that scale. So good point is that, as Jérémy was mentioning, steel and cement are the elephant in the room. But the good point is that elephants have started dieting and they know that there needs to be decarbonization that need to happen in this space. So already, the cement industry, concrete industry led by GCC has announced the roadmap to become carbon neutral. And at the same time, simultaneously, there are, collaborations happening. For example, First Movers Coalition. So Dalmia, Holcim, and other companies are also part of that First Movers Coalition. And their demand commitments are taking place. Even at premium, people are saying that we will buy the materials which are low carbon. There are various sectors covered in that, and cement and concrete is one of that. And as a member of First Movers Coalition, we also say that whether it is zero carbon steel or zero carbon concrete, we will also take it and we will also buy it, considering its potential of zero carbon. So a lot of actions are happening, a lot of collaborations are happening, but ultimately, particularly for the cement and steel industry, where most of the demand comes from the public sector, and to create sustainable market, it's very important that there are public commitments, there are public procurement policies in place. Without that, it will take a lot of time, basically, to market, to develop themselves. And secondly, it is also important to make aware the end users, because whether it is a car, whether it is a house, the cost of material for the end user, decarbonized material for end user, is not very high. So from that point of view, also it is very important that end users are adequately educated and brought into this discussion of individual carbon footprinting, family-wise carbon footprinting, embodied carbon footprinting of their house, their buildings. So that can also be an important part in this entire discussion.
Great. And so, I mean, your wish to policymakers would be, on the one hand, you want to, I think, address this question of public procurement. Anything else? Like,
yes,
you know,
yes, there are many asks. In fact, another one is, as I was saying, carbon markets. They have been very, very crucial for the developing countries in the past, and those carbon markets should be definitely. We should have global access to those carbon markets so that more technologies, whether it is renewable energy with the storage, whether it is carbon capture and utilization. And let me give you an example. We have, collaborated with ADB, and ADB has supported us in development of pre-feasibility of our carbon capture and utilization project, where the outcome of the study was that either there should be a demand commitment for the green product, there should be subsidized renewable electricity or commercial renewable electricity at very, very affordable economic rates, and there should be a carbon price, basically the carbon credit price of around $50 to $60 to make this suitable, to make it affordable and economic. So these are some basic points which needs to be addressed for deep decarbonization. As far as the existing levers are considered, we are already taking actions on the existing levers. But then the advanced levers like carbon capture, green hydrogen, there is a way forward. There is a visualization of the future, but then some enablers are needed at the same time in order to reach to that particular level. And those enablers are like green finance, green grants, enabling policies of renewable electricity to reach to that.
Thank you. Yeah, that was a very concrete ask. Thank you. Chitra, I think we're approaching kind of like the end of our discussion. So I think you might have the final word. So kind of like from your perspective, like, you know, I think you're very much kind of like you have a vision about what buildings could look like. What do you see, like your colleagues, your profession, what would be needed to, maybe also your clients, right? Like what would be needed to basically increase the type of resource efficient kind of like, yeah, I mean, low carbon is an overused word, but let's say these, the buildings that are a bit less damaging than some of the buildings that we currently construct. What is needed to basically increase their uptake?
Yes, so there are a lot of points which had come up from previous speakers about it. One of it is that incentivizing this kind of construction. So one of it is that in India, we are not paying the ecological cost for buying cement or steel. And I think the ecological cost, once it's there, obviously they would buy lesser of cement and steel. Yeah. And then there is need for, sorry, yeah, yeah. So there's also need that people know the limits of construction, to understand it, because the way reinforced concrete is used, it's used in places where it's not needed, and where steel is needed, if it's used, you would use less of steel. You don't need that much of steel. Why do we use steel? And that's also to do with design. Why do we use steel in landscaping projects? So we have to really get to be extremely in terms of understanding limits, and through design, how do we achieve this? Where we use which material? These two are very important factors for me. And scalability, I would say, again, I'm taking my city's example, and from 25 years since when we built our house and we started building with earth, now in Bangalore, there are about 7,000 stabilized earth structures, largest in the world. There are about 250 architects working with earth structure. There are at least now about 20 vendors. Asmae, they make blocks and sell. But now there is always a negative side to it, because we don't know where they're getting the earth from. Are they taking earth somewhere else and taking it away? Whereas what we talk, and I've shared it also, how could the buildings be the source of material, source of resources? So when we make a basement, one basement soil is enough for 3 homes. You see, it's not for 1 home, but 3 homes can be built with that soil. So somebody doesn't have a basement, doesn't need it or cannot have it, they get the soil from the very city. it's below your feet. So it's also very important that that's a place where there is no biological activity happening, and that's where you get the soil from, not from somewhere else. Where is the material coming from? Understanding the limits of how much you need, how much you build. And with all that, it's very important because right now we start only quantifying or we talk about the money spent on land. So we're making tall buildings. The tall buildings take more energy to maintain, more energy to live, and much more energy to build. And there is obviously with that the full carbon. India still builds 70% of its home not more than ground plus 2 floors, the 3 floors, and that could be structurally just be load bearing. Why do we need RCC at all? So these are the things which we have to be talking about. And great, Anupam, if we can get that kind of cement most easily possible, we'll all use it, because why do we have to have fast setting cement? So there is need for design, there is need for financing, there is need for structural engineering. Everybody has to come together to be able to talk about this. And I think I should just end with this. Thank you.
Thank you very much. And I think, yeah, I think we could talk for another hour, probably.
Yes.
And we will have to stop at some point, which is now. I would like to maybe, let's start with this. We would like to hear from our audience about, you know, was there anything you particularly liked and that you maybe would have wanted otherwise? You know, anything you want to tell us. Harsh posted a little question in the chat, takes 30 seconds, 1 minute. You know, do let us know. I think that would be really great if we hear from you. I do have a few, well, several takeaways for us. So I think we did not get into the question of jobs and laborers. I think it's a huge question when we talk about embodied carbon. I think very much what came out of it, also what you just said, Chitra, no, is kind of like we have to appreciate, no, the materials that we use. No, I think we have developed wonderful building materials, you know, and the question of how we use them and how much we want to use them, I think is really a big one. So I also take, I mean, I heard you talk about also in the chat about that question of like, how do we actually, to that point that the speakers really highlighted, that question of like transparency and knowing, kind of like, you know, what does the consumer know? What do we know, you know, as a policymaker about what's actually happening in that country? And then, and yeah, I think, Jérémy, we could talk a lot more about this, like, how can you actually incentivize it, no? I think it's really, I mean, there's several blocks that are too much for this like 1.5 hour session, but I think, yeah, everyone here will be very much kind of like continuing the work on this. So with that, I would like to thank our presenters very much, but we are not finished because I can hand over to Jonathan, who basically can tell us, you know, the GlobalABC is very engaged on this issue. You know, what are the takeaways? What is the work coming up? You know, how will this be attacked, addressed in GlobalABC, and what can we expect? And also, how could people maybe engage? Jonathan, floor is yours, and you have kind of like the closing of that session.
Thank you, Anna. I mean, I think it was really great to hear all the presentations, to hear that the solutions are there, that I mean, to a certain extent, I'll say we don't have all the solutions yet, but there are a lot of solutions. There are a number of actions already being taken. But one of the key things that I take away from here is that a challenge is still like making the information available to everyone and in a way that people actually can integrate, understand the information properly. And I think that's where the GlobalABC basically really wants to take a major step this year, as we are going to develop a major study on the issue of embodied carbon in materials, which would lead to a number of key recommendations specifically for policymakers. I also say that specifically because, I mean, as it was said by Anupam, when we hear that, you know, about 40 to 60% of the public procurement is actually where most of the materials come. Well, you know, making the difference and succeeding in market transformation, in a sense, is like if the government actually starts really taking a step, well, the market will have to follow. Otherwise, they're out of market. I mean, also, I mean, the industry, in a sense, will have to follow. So So I think some of the key things on our side is really to try to actually really demystify a little bit this whole issue of embodied carbon, show that there are a lot of opportunities and benefits specifically with local materials, also for local economies, as we discussed earlier, and you mentioned jobs at the end. This is certainly a way for us to sell it also to the governments that this can actually bring a lot of economic benefits, and politicians certainly like to have that type of things. So that's kind of like, for me, one of the critical things is actually making this information available through the study, but then we're also going to establish a platform under the GlobalABC on materials, where we want to be able to collect, well, this information, package it properly, and actually ensure that, the different actors have the access to all these different points. What I think also that I thought was really interesting is that, there are a number of solutions that are actually not a high cost. And often when you hear from project developers, they feel like, oh, greening my building, it's actually going to cost way more and it's going to be really difficult for me. How can we convince them and show them that it's actually not the case? And I think that's a really important thing also if you want to be able to change the trends in the market. We mentioned, of course, also the demand and the people who live in houses and certainly have a role to play also. and actually it's also it's not only awareness raising of actually all the people that are like the decision makers, but it's also about the population, because they can also drive change in markets. And then some of the levers I think we discussed, procurement certainly. Certification related issues, I think also very important, labeling, because this can really also accelerate some of the market transformation. I mean, then I still have a little bit of a challenge somewhere with all this, because a lot of the housing that is constructed is self-constructed. And I think Chitra was the one who has been showing quite a bit about that. Asmae also, because a number of the buildings in her construction, all that are coming from those communities. And it's actually a wide stock of, like in some countries, they say 70 to 80% is actually self-construct. And so, it's not only about getting the industry behind it, but it's also like, how can we actually change the things for that segment of the housing? And that is still something where I think quite a bit of thinking and work will be required. And a last point maybe is that, we heard it from everyone. I think innovation still needed. So solutions exist, but as Asmae showed also, some of those solutions that have been existed for a long time ago can actually be improved with a little bit of innovation, and actually can bring some of those products that maybe a lot of people think, oh, they're old fashioned, they're not so good, actually give them a little bit of a sexy thing again, so that everybody kind of feels like, yes, these are like, it's not like the old material for the poor people. It's actually also the alternatives, I think, are some things that need to be promoted there also. But I agree, getting these to scale is not easy. So in any case, we can't avoid also working with like the mainstream materials where luckily to see there's some action already being taking place, but there also innovation and R&D is also needed. It was also raised by Anupam. So innovation and R&D is a very critical element. Of course, it can take time and we want to move quickly. So as usual, I think we need to take an approach where we are strategic, but also opportunistic.
Thank you very much, Jonathan. Thank you very much to all our presenters. Thanks also for that very engaged audience. It was really a pleasure discussing with us. And yeah, I think we have our work cut out, right? Yeah, I think it's great that we're kind of like raising the attention on this issue. It's really the time to see how we can drive the solutions and get to scale. So with that, thank you very much. Was a pleasure, and we hope you have a really good start of the day, end of the day, or lunch. So thanks a lot. Yeah, and we will continue this discussion.
Thank you, Anna. Thank you, everybody.